In this example, we are going to find the box with the smallest surface area whose volume is 12 cubic feet and the width is twice the depth. Okay, this type of problem can be, for example, imagine that you were trying to spend the least amount of money in cardboard to produce these boxes, okay, for a given product, and you need to minimize the cost of the cardboard. So that you would want to spend the least cardboard possible, so you would want a small surface area. So in this case, we have the three variables: the height, and the width. Let's copy that. And the length, like that. Okay. There we go. So we have, let's say this is the width, this is the height, and then we have the depth. Okay. So what are the specifications? So it says the width is twice the depth, and that's it. So we have, let's say that the depth is x and the width is 2x. Okay, and then the height, usually for a vertical coordinate, you use the z variable. So let's call it z. And here what we know is that the volume, which is, well, it has to be 12 cubic feet. Okay, but we know that the formula for the volume is going to be the width times the depth times the height. Okay. All right. So, but here we can put together the two pieces of information. This equals 12. So that means that z is going to be 12 divided by 2x squared. That means 6 divided by x squared. Now, the surface area, that is what we want to minimize. Well, let's write first the surface area, then the surface area is going to be 2 times 2x squared. This is the bottom and top of the box, okay? And then we have the two walls that are 2x times z, okay? Those are the front and back. Okay, in the picture will be this one here and this one here, okay? Then we have the sides, okay, which will be the next term. So we have two sides, but they are like x times the height. These are the sides, okay? And then we have the bottom and top. All right, so with this information, let's see what we can do. Now, first thing I need to get rid of is the z, right? So this is 4x squared plus 4x times z, which is 6 over x squared plus 2 times x times z, which is 6 over x squared. There's a cancellation there, okay? So we have 4x squared plus 24 divided by x plus 12 divided by x. So that makes 4x squared plus 36 divided by x. Okay. So let's minimize this function. Minimize a of x equals 4x squared plus 36 divided by x. A prime, this is 8x plus 36, actually minus 36 divided by x squared equals 0 if and only if x to the power 3 equals 36 divided by 8. Okay, which is 9 divided by 2. And that means x equals the cubic root of 9 over 2. Whatever that number is. Okay, because of that, we know right away that y has to be twice as much. So 2 times the cubic root of 9 halves. And then the only missing measurement, the only missing quantity is z, the height, which remember was given by 6 divided by x squared here, right? That is 6 divided by 9 halves to the power 2/3. So that is 2 divided by 9 to the power 2/3 times 6. So that is 2 to the 2/3. Well, let's keep it like that. I don't think it's going to look nice anyway. Okay, so these are the three sides of the box. Notice before we always found like cubes and things that were very symmetric, but that was because the problem itself had a symmetry. Okay, there were several sides that could look the same. In this case, because we know already that the depth and the width have to be completely different, that breaks the symmetry and we get a box that has different measures in the different directions. Of course, last thing we always need to check is that this is a minimum. Okay. And here we need to check that a prime of x is positive on the right and negative on the left, but we actually need to check it. Okay, so a prime of x equals 8x minus 36 over x to the power 3 less than 0 if and only if 8x less than 36 divided by x to the power 3 if and only if x to the power sorry, not 3, it was 2, right? So we have x to the power 3 less than 36 divided by 8. That means x less than cubic root of 36 divided by 8, which is our 9 halves. Okay, so we have a prime less than 0, and then for the bigger, we just need to check. Okay, but you do this part. Okay, and we get that a prime is bigger than 0 on the right. Okay, that means a of x is decreasing and then increasing. So the cubic root of 9 halves is a local minimum.